Let's solve a linear systems application word problem together. For this particular example, we're going to deal with a mixture percentage concentration problem. Here's the problem. For extremely cold temperatures, an automobile manufacturer recommends that a 70% antifreeze and 30% water mix should be used for cooling system for a car. The question is how many quarts of pure 100% antifreeze mixed with a mixture of something that is 50% antifreeze and 50% water should be combined to make a total of 11 quarts that is 70% antifreeze and 30% water. So basically what we're doing here is that we're taking some pure 100% antifreeze, which is 100% antifreeze and 0% water, and we're mixing it with another solution that is 50% antifreeze and 50% water, so it's half and half, in hopes of combining these two and then making 11 quarts that is 70% antifreeze and 30% water. So that's the goal that we're trying to get there. Now if we just used all of bottle 1, then we would have too much antifreeze and not enough water. And if we used all of bottle number 2, then we would have too little antifreeze and too much water. So we have to figure out the right balance here between the two different solutions so that we get the perfect 70% antifreeze and 30% water. Hopefully we now understand the situation a little bit better, so let's go ahead and define two variables so that we can write a system of linear equations. Let's let x represent the number of quarts of antifreeze, and let y represent the number of quarts of water. Next, let's go ahead and set up two linear equations. For equation number 1, let's go ahead and write this equation. We're going to go ahead and write x plus y, and this is going to equal 11. Hopefully this makes sense because we're adding quarts of antifreeze with quarts of water in hopes of getting a total mixture of 11 quarts because that's what we're being asked to do here. This first equation represents the total number of quarts. For the second equation, let's go ahead and write that we have 100% multiplied by x plus 50% multiplied by y, and this is going to equal 70% multiplied by 11. Now this equation is a little bit more complicated, but basically what we're saying here is that we have x quarts of this 100% antifreeze mix plus y quarts of the 50% mix, and we're adding those two together to get a final 11 quarts of this 70% mix here. This second equation tells us the number of quarts of antifreeze that we're going to have. Now, simplifying this equation a little bit, if we have 100% times x, remember that 100% as a decimal or as a non-percent is just going to be 1, so it's going to be 1 multiplied by x. And then we're going to go ahead and add that on to 50% times y. Well, 50% as a decimal is going to be 0.5. We're going to multiply that by y. And that's going to equal, let's see, on the right side we have 70% times 11. So 70% is just 0.7. We're going to multiply that by 11. Okay, simplifying this just even a little bit more, 1 times x, we know that's just going to be x, hopefully. And then plus, let's go ahead and say this is going to be 0.5y. I'm going to go ahead and just keep the 0 in front. Totally up to you if you want to drop that. And on the right side here, we have 0.7 multiplied by 11 here. So 0.7 times 11, and that's just going to equal 7.7. So here we have one equation of x plus y is equal to 11, and then our second equation here is x plus 0.5y is equal to 7.7. Let's take a look at these two equations and solve it as a system of linear equations now. So you can totally choose if you want to isolate this x or this y, or maybe isolate even this x over here. But I think what I'm going to do is I'm going to isolate this x in the first equation. And then once we know what x is equal to, let's go ahead and swap that out for the x in the second equation, right? So taking this first equation of x plus y is equal to 11, let's go ahead and solve for x or just isolate it. We can do that by taking away y from both sides of this equation. If we go ahead and do that, then we're just going to be left with x equals, we'll have x is equal to, and then we're going to have 11 minus the y on the other side. Okay, so now that we know that x is equal to this 11 minus y expression, we can go ahead and swap this x out for this 11 minus y. Now before doing that, if you want to take this whole second equation and multiply it by 10, just so you don't have to deal with decimals, feel free to do so. I did that in a previous video as a strategy to help you not deal with decimals. But for this example or this practice problem, I'm just going to go ahead and use it as it is. So let's go ahead and just replace this x right now with this 11 minus y expression. So for the second equation, let's change out x for this 11 minus y. So write 11 minus y. Okay, we're going to swap that out for the x. And then that's going to be added onto this 0.5y, 0.5 multiplied by y, and that's equal to 7.7. Okay, cool. So we have one equation now that only has one variable, right? It just has y in it. So we can go ahead and drop these parentheses. They don't need to be there anymore. I just wrote them for substitution. So it's 11 minus y plus 0.5 times y, and that's equal to 7.7. Now we have an equation with just one variable of y, so let's go ahead and combine some like terms over here on the left side. Now keep in mind that this is a negative 1y plus a positive half y. So negative 1 plus positive half, that's going to be negative 0.5. So it's going to be negative 0.5 multiplied by y. And then we still have plus 11, and that's equal to 7.7. Now to solve for y, let's go ahead and subtract 11 from both sides of this equation. If we go ahead and do that, the 11s are going to cancel out on the left side, so we're going to have this negative 0.5y on the left side. And then on the right side, we have 7.7 take away 11. I think that is going to be negative 3.3. One more step for solving for y here. Let's go ahead and divide both sides by negative 0.5. That way we can get y completely isolated. A negative divided by negative will be positive on the right side. So we can go ahead and say that y is equal to, and if you divide by half, you just really multiply by 2. So this should just equal 6.6. So that should be the value of y. Knowing that y is equal to 6.6, that means we need 6.6 quarts of that 50% antifreeze and 50% water mix. But what about how much of that 100% antifreeze solution do we need? Well, we can go ahead and plug that into either this bottom equation, or we can plug it into the top equation to solve for x, which is the number of quarts of that 100% antifreeze mix. That top equation looks a little bit nicer to use, so let's go ahead and swap out that y up here for 6.6. Okay, so I'm going to say x plus this 6.6. I'm just going to go ahead and write 6.6 since it's positive. Okay, and that's going to equal 11. All right, so if we need 11 total quarts at the end, let's go ahead and say, let's take away the 6.6 quarts of that 50% mix. Then if we go ahead and subtract that, then let's see, the 6.6 minus 6.6 is 0. So x would equal, I think that's going to be what, 4.4? So the rest of the solution must be made up from this 100% antifreeze, which is 4.4 quarts. So if we were to have graphed these two linear equations, we would have seen on a coordinate plane that they would have intersected at the point 4.4, 6.6. But you can see here that we solved it algebraically, and this would be the solution. However, for this particular problem, we now know that if you mix 4.4 quarts of that 100% antifreeze solution with 6.6 quarts of that 50% antifreeze and 50% water mixture, you will then get 11 total quarts of 70% antifreeze and 30% water mix, which is what we were looking for. And that wraps up this video on this practice problem dealing with linear systems on this mixture application problem where we go ahead and write a system and use substitution to solve it. If you found the video helpful, please consider giving it a thumbs up. Remember that you can also check out the description and download a blank PDF of this worksheet, as well as the annotated or answer key PDF as well. And you can go ahead and use that in the future if you would like to as well. So keep up the great work that you're already doing, and I'll see you in the next one.